For which values of x the series is convergent series? First of all, remind yourself of a geometric series. A geometric series was defined as the summation of a times r to power n minus 1, and starts from 1, goes to infinity, and as long as the ratio r has the following properties: absolute value of r is less than 1, or r is bounded between -1 and 1, this guy is convergent to a divided by 1 minus r. So let us rewrite this series, and you get the summation of -5 times x to power n starts from 1, goes to infinity. So I just combine these two because they have the same base. And as you can see, it fits into the pattern of a geometric series. But what is the ratio here? The ratio here is -5x. This is your r. And we want to find the values for which values of x the series is convergent. So you're going to write since we have a geometric series, as long as the ratio r is bounded between -1 and 1, then we have a convergent series. So what is my r? My r is equal to -5x. Absolute value of r is equal to absolute value of -5x. It must be less than 1. Okay, I can break this guy down into absolute value of -5 times absolute value of x, and it must be less than 1. But absolute value of -5 is equal to absolute value of 5, which is basically 5 itself. So you end up with 5 times absolute value of x less than 1, divide by 5, and absolute value of x is less than 1/5. So your x must be bounded between -1/5 and 1/5. As long as our x is bounded between -1/5 and 1/5, then we have a convergent series. So as long as the x is bounded between -1/5 and 1/5, the series, the summation of -5x to power n starts from 1, goes to infinity, is convergent or approaching a divided by 1 minus r, or -5x divided by 1 minus our r is -5x, so you have a parenthesis, so it's equal to -5x divided by 1 plus 5x, which is a function. So let us take a look. The summation of -5x to power n starts from 1, goes to infinity, which is -5x plus -5x to the second plus negative 5x to the third plus the rest of the terms. Or we have negative 5x plus 25x squared minus 125x cubed plus the rest of the terms. Guys, this is the sum of polynomials. This sum approximate negative 5x divided by 1 plus 5x, which is a rational function, as long as my absolute value of x is less than a fifth, or x is in between negative a fifth and 1 over 5. You can take a look at Desmos and actually visualize this. Let us pull up Desmos and show you how this guy approximates this function. Now let me share the screen. So if I have 5x, negative 5x, negative 5x divided by 1 plus 5x, this is my graph, all right? And if I take a look at the polynomial, negative 5x plus 25x squared minus 125x cubed. Wow, take a look. The blue graph is my polynomial. Around 1/5, which is going to be here, the graph actually approximates this value between negative 1/5 and 1/5, which is around this area. These two graphs are very, very similar to each other. They're very close by. So this is the basic of the idea behind these types of series that we call power series. These are basically functions that approximating other functions. Here we go.